Perfect. So, as I said, my name is Anthony Seto, and today we're going to be talking about protecting the prompt and more. So, if you haven't heard enough about AI, you're going to hear more. And if you don't want to hear about AI, you're probably in the wrong session, right? But AI is changing the world we live in. How many of you remember back in the late 90s, maybe I'm dating myself, when IBM's Deep Blue beat the world champion at chess? Yep, see some hands, all right? That was a pretty, for me as a technologist, that was a pretty pivotal moment, right? It's the first time you saw a computer do something where it had to sort of think on its own, right? And now here we are some 30 plus years later, and AI is completely different, right? The AI of today is not the same as the AI was back in, again, the late 90s, right? And Gen AI is everywhere, right? We use it in our everyday environment. We're using Gen AI to create prompts to do things like, co-pilots and automation and digital pilots and assistants, right? AI is everywhere. And this is great, but now we have a lot of challenges, and I'm sure you've heard about some of them today with some of the other speakers. But largely, the challenge becomes, from a security perspective, how do you find that balance? How do you find that push and pull between letting your users use AI, but also securing the infrastructure, right? Securing the environment. And the challenge when you look at this slide is largely sort of a push and pull between where you are in this AI journey, right? So if you're on the left, maybe you're just trying to figure out who in my environment is even using AI tools, right? A year ago, this was a problem that just about every executive that I talked to wanted to solve. I just need to know who's using ChatGPT, what are they sending there? If you're on the right side of this slide and you're building AI services, that's a whole other ballgame. Now we want to make sure that we're building AI services that work, that tell our users what they need to hear, but also don't say things they're not supposed to, right? So the panelists just talked about the Chipotle thing, right? Whether it's Chipotle, whether it's McDonald's, whether it was a year and a half ago, there was a car dealership where somebody said, hey, I negotiated a $100 Tahoe, and I want to go pick up my Tahoe. And the dealership said, no, we're not going to give you a Tahoe for $100, and they sued and they won. Because when you create AI services, you're responsible for what those AI services tell you, and for many of us, you're also liable for what those AI services say and do. And then, of course, if you haven't missed it, agents are all the rage right now, right? I feel like we went from worrying about AI we create to how do we secure the agents that are now running wild in our environment that are doing things for us. And so this is a real strong push and pull that we as security practitioners still have to figure out. So there's a bunch of people in this room, so what I usually like to do is sort of do a baseline, right? Let's all just get our collective baseline about some of the terminology that you may have heard, that you will have used, or that you are using, before we sort of jump into kind of the key 3 use cases I'm going to talk about today. So what I'll talk about today is, number one, just defining what's a model, right? You probably hear the word model a lot. What's an application and how is it different than a model? What are some of the third-party repositories for where I can get code or where I can go get my models? And also, what makes an agent and this thing called MCP that you may or may not have heard of. So what is a model, right? A model is basically a mathematical system. It's a component that has been trained on data that allows your service to predict what the next answer is going to be, right? A model is just a big probability equation, essentially, right? It basically helps you figure out, based on the data it's been trained on, what the next word in the sequence is, right? So if I ask a model, what is the capital of France? It's going to say, well, let me go look at my data and let me predict the next answer. So Paris is probably what it's going to spit out because that's got a strong weight, right? It could also say the probability of the next word being tomato is probably like 1%, right? Because again, it's learned how to predict what that next model is. Now, a model by itself doesn't do anything, right? A model is the brain, but ultimately we take these models and we put them into applications, right? And applications is ultimately what allows us as users to interact with these models. So the key is models don't stand alone, right? They're basically embedded inside of a larger application. So let's dive into this a bit more. So as I said, I'm a big car guy, so a lot of my analogies that I use when I present are based on cars, right? But think of the model as the engine of a car, right? Now, when auto manufacturers are building cars, sometimes they build new engines, but oftentimes they have a stable of engines that they build from, right? They take something, they tune it, they put it with the chassis, they put all the parts together, right? Because you can't drive an engine, right? You drive a car, and that car, a good car in my opinion, has a good engine, and that really defines the driving experience. But there's also the tires, the chassis, the steering, right? There's all these different pieces and parts, right? Supporting members of the band, if you will, that make our application or our car run. And so what do you do as practitioners when your developers are starting to build models, right? How do you secure that? But at the same time, how do you build applications today? You're probably going to go get a model. You're not going to build one from scratch, right? And so these models ultimately are the engine that makes everything run. So if you look at some of the marketplaces, right? They have models that are available, and that's where you go and you download them, and that's what you run when you build your AI application. So if you're an AWS customer, there's SageMaker and Bedrock Marketplace. If you're in Azure, there's AI Foundry. If you're in GCP, there's the Model Garden, right? There's also something called Hugging Face. How many have heard of Hugging Face? So probably a mix of hands, right? So Hugging Face is sort of the GitHub of models, right? Hugging Face is this repo that has millions upon millions of models that you can download that cover just about every use case you can think of. It's super useful if you want to develop AI because you can find a model that does just about anything you want. From a security perspective, the problem is that there's millions and millions of models for every single use case, and you have no idea if the models that are up there are safe or malicious, right? And so this is where you have to start thinking about where you source these from because you have to make sure that your model that you are building on for your applications are safe and secure. Now, what about agents, right? So depending on who you ask, there's you might get a slightly different answer, but ultimately what makes agents different are these 4 pillars right here, right? Agents have autonomy, meaning you give them a task and they go do it. Now, in order to be able to do these things, they have reasoning, right? They need to be able to reason. They need to understand, what did I try so that I can figure out what I need to try next, right? AI agents also have access to tools, right? They have the ability to go talk to multiple systems. This is great because you give them the ability to go talk to whatever system they need to do whatever they have to. The challenge is they have access to all these systems. So when it comes to identity and access, what do you give an agent? Do you give it the same privileges you give a user? Do you give it more because it is an agent and it's not a user? Or do you give it less because it's an agent and not a user, right? The other thing is agents typically have memory, right? They can remember what they did. That's how they're smart. That's how they can figure out, okay, I tried this, it didn't work. Let me go try something different. And so we'll get more into agents towards the end of the presentation, but just know that agents are autonomous, right? They do something that you ask them to do, and they figure out how to do it, and they're pretty good at doing it now. What about MCP? Has anyone heard of MCP? Okay, a little bit less hands, but something that you will start to hear about a lot. So MCP is a protocol. It's called Model Context Protocol. Think of it as a universal translator. It is a way for AI agents and services to talk to other services, right? Now, a year ago, MCP wasn't really a thing. MCP was basically a protocol on a piece of paper, right? And I was listening to a talk last week from an AI conference that was, I think, over in Germany, and they had someone from Anthropic speaking about it, and he basically said, 12 months ago, MCP was nothing. Now, the MCP SDK that developers use to develop applications that use MCP is being downloaded at a rate of 110 million downloads a month. It has surpassed the React framework as largely the fastest downloaded open source development platform. So everywhere you look, you're going to see MCP. This is how you build applications that talk to other things. So if I'm building an AI agent or an application and I wanted to go, I don't know, talk to Gmail to read my email, I don't have to go teach it or code it. I can just go download an MCP server that's been provided to me, and now my agent can talk through that protocol and know how to talk to all these different systems. MCP also allows you to do things at scale. So if you have a bunch of applications that all have to talk to a SQL database, instead of having those developers write in their code how to talk to the SQL database 100 different times, you just point it to an MCP server, and you can do a one-to-one or a one-to-many or a many-to-many relationship for your agents or your services to talk to other systems. Now, the last thing I'll talk about here before we kind of jump into the use cases is the one thing that I always like to call out, because I came from the data space before really jumping into AI, is that at the end of the day, your data, is what differentiates your AI services from your competitors or from other services, right? The services that you deliver with AI are doing things for you based on the data you give it. So while we're all really focused on securing AI, you have to remember to secure your data, right? Securing your AI and securing your data, they go hand in hand. Okay, so AI, and this is sort of Palo's approach to AI, right, is AI is really complicated. It's not just an endpoint problem. It's not just a cloud problem. It is an everybody problem. So as practitioners, where do you tackle it? Where do you start? Because there is no shortage of platforms out there that do AI security, right? So when I meet with executives, and I've had 21 executive briefings in the last 3 weeks, they're all concerned about something related to one of these use cases, right? So we're going to dive into each of these. So we're going to talk about protecting the prompt, protecting the response, and protecting the action. Bless you. So when we talk about protecting the prompt, what we're really talking about here is how do I protect the data leaving my environment, going to some third-party application? Again, this was the concern, I would say 12 months ago, 15, 16 months ago, when AI first really became more mainstream. This is that typical situation of, I just want to protect my data, and I want to know who's using what and where's my data going. Because if I don't, there are a lot of risks. And what are some of those risks? So the first one, my data privacy and intellectual property. I want my data to stay with me, right? So I'll give you a great use case, right? You're I'll pick on my Palo Alto team, right? You're a sales rep and you want to present to a customer the roadmap. Now, we have these great AI tools. Now, we at Palo provide AI tools, but at any organization, you can just get on a laptop probably and log into the AI tool of your choice. So let's say I go to ChatGPT and I say, hey, ChatGPT, here's my product roadmap. I want you to sum it up and make it concise so that I can go present it to my customer. Well, unless you're using an enterprise version of an AI service, your data is going to a public model somewhere. And that data, it's out there. It's not coming back, right? It's being used to train the model. It's potentially being accessible by developers who want to tune that model. Or in some cases, you have companies that can sell your data, sell their data to other companies, right? So now, a couple weeks later, you have a competitor who's just on ChatGPT saying, hey, what are people doing in this firewall space? And next thing you know, your roadmap pops up, right? Because you just shared your intellectual property with a public model. Now, the other challenge that we hear a lot about is shadow AI. So this is a play on shadow IT, right? As security practitioners, I just want to know what AI services are in use, right? Because I may give my employees ChatGPT as the go-to AI service, but if I'm not blocking them from Gemini, what's to stop them from saying, you know what, I don't really like ChatGPT, I like Gemini. I'm going to go to Gemini, and Gemini is going to do my work for me, right? But Gemini is not an approved service, right? And so these are things you have to think about. And then maybe the other one is malicious content, right? So again, for me, and maybe some of you all, I use AI instead of using Google, right? I don't really Google things anymore. I ask AI, and it will give me an answer, or it will go fetch an answer. So if I ask AI, hey, I'm developing an application, and I want a specific flavor of Java, it's going to go search the internet, and it's going to return a link to me, and I'm going to click on that link, because I'm dumb and I trust that link. But should we trust it? Not always. How do we know that link is not malicious, right? So this is where we have to start thinking about the risks of using generative AI and the risks of having to protect the prompt. So how should you guys think about doing that? So there are two common ways that we think about it here at Palo. The first is the secure enterprise browser. The second is the network layer. And each of these have their own strengths and sort of weaknesses, right? Now, between either of these solutions, whether they're from us or from anybody else, they have a lot of commonalities, right? Whether you're using a secure browser or an advanced next-generation firewall, they're going to be able to do DLP, malicious URL, malware inspection, right? They're going to give you reporting on governance, right? They're going to tell you who's doing what. The difference between these two is the point of enforcement, right? The web browser is a great place because I can look at web traffic. And I'm betting that 90% of us in here, we start our day in a web browser. Either we open up Chrome or Safari or whatever the flavor browser that you like is, and either there's a million tabs that are open, or we add just another one to that, right? But most of the stuff that we do happens in a browser, right? Because the web is largely where people do business now. And so the web browser is a great place because in the web browser, I don't have to worry about decrypting SSL traffic, right? I can see it all within the browser, what someone's doing, what they're accessing, and ultimately be able to do enforcement. It's also great if you're doing bring your own device, right? Whether you have a BYOD policy or you have contractors, the secure browser is a great way to give people access to AI services, but still be able to have some governance around what they can go to, what they can do, what they can and can't send. Now, the challenge with the web browser is it's just for web traffic. So if you've got Grammarly installed on your laptop, right, Grammarly talks across the network, but Grammarly doesn't necessarily go through the web browser. So this is where the network enforcement comes in, right? So regardless of which way you go, you have to start thinking about the various ways that you can enforce protecting the prompt. And for us, that's all about doing it at the network or doing it at the web browser. Now, regardless of who your vendor is, a lot of times turning on these network protections can be as simple as buying a license key or turning on a feature, right? Some of these things are built into current next generation firewall. So again, as you think about protecting the prompt, these are two ways that you can do it. Now, what if you're making AI services, right? What if you are now delivering services and you're building AI within your environment? This is when we talk about protecting the response, right? Because yes, we can protect the prompt. We want to protect the data leaving and going to our third-party apps. But now we want to make sure the things that we are creating are, again, saying what they're supposed to say, doing what they're supposed to do. Because if we don't, we have a lot of risks, right? So the risks of not protecting the prompt aren't that dissimilar from the risks that we saw in application security or app development, right? The biggest one is the malicious code or the Trojan horse. Again, we talked earlier about Hugging Face. I can go and download millions of models on Hugging Face. I can tell you right now, they're not all secure, right? Threat actors are putting models up there that look benign, and when you download them, they can install backdoors in your environment. And what's crazy about AI models is that I don't actually have to run a command against the model. Just the process of loading a model into memory can execute malicious code. Another thing that we're seeing is supply chain attacks, right? So one of the ones that we've seen is something called namespace hijacking, where essentially you have a trusted vendor that is putting models on some place like Hugging Face. Maybe that vendor decides they want to rebrand or they want to change their name. The minute they step away from that domain name, essentially, somebody is buying that name and putting models that look like their models on Hugging Face. So if you've built your AI development into a pipeline, the next time you go and you pull the latest version of a model, you might be pulling down a bad version, and you would have no idea. And then the last thing is model poisoning, right? So you have all these models deployed in your environment. You still have to enforce good posture, right? You have to make sure that people can't write to your model. Because if you have a publicly writable model or you haven't put good permissions around it, it's really easy for someone to go and poison your model. And it doesn't take a lot of bad data to corrupt what your model says, right? So the example that I often use here with customers is if you're in healthcare and you've got an AI chatbot that's supposed to help a nurse figure out what the right clinical dosage is for medicine, if someone poisons that model and the nurse goes and asks that model for what is the right dosage for morphine, the model might give you a wrong answer, right? And that becomes a big liability in a variety of different ways, right? So again, it's really important that you secure the models that you develop and really you secure the entire development process. So if any of you have lived through the AppSec or the DevOps world, this type of chart might look familiar to you, right? So AppSec was really sort of the first foray into this whole mentality around shift left, right? How many of us remember shift left, right? It's all about how do we take security and build it earlier into the development lifecycle of our applications. What we are saying is you need to take that same approach to when you build models, right? And so what does that mean? That means at the very beginning of the lifecycle, before you even write a bit of code or deploy an application, you need to do model scanning. You need to scan your models to understand, are they safe? Whether these models come from the marketplaces or they come from the open source repos, you have to make sure you're starting off with a fundamentally safe model to develop your applications on. Now, at the same time, when you deploy these models and you deploy all the other supporting members of the band, if you will, into your cloud environment, right? These could be vector databases, these could be VMs, these could be identity services, right? Again, these are all the supporting members of the band that AI needs. You have to make sure that their posture is safe, right? That means using tools like AISPM or AI Security Posture Management to scan your cloud so that you can understand, number one, what even exists in my cloud? Do I know what developers, what people are deploying in my cloud? And how are these things configured from a posture perspective? You also have to look at the dynamic risks, right? You have to be looking for behaviors, right? Do I see things that are happening in my cloud around my AI assets that is abnormal from what it typically sees, right? Because again, threat actors are going to try to attack you, and you need to be able to look for these behavioral differences, not just looking at the static posture. So we've built this model, we've downloaded this model, we know that this model is good. The next step is, before we deploy, we want to do red teaming, right? So red teaming in the model world is all about using technology, using tools to make sure that your model does exactly what it's supposed to, that it has the guardrails, that it responds properly to the things that you want it to do. So there are tools out there that will leverage curated prompt sets, right? So it'll ask your AI a variety of questions based on a variety of topics. These can be security topics like jailbreaking, remote code execution. It could also be things that are less security related, but still things you need to think about. Does your model have bias, right? Does it use violent language? Does it talk about drugs? Depends, again, on your use case, right? The joke that I always say is, do you want your model swearing at your users? The answer is no, right? But if you guys ever want to have a good time, go to Grok or go to Claude or Gemini and type in, talk to me like an unhinged maniac, and then start asking it questions and see how it responds to you. It'll start talking to you in a whole different tone that AI has not talked to you in. But red teaming ultimately is about mitigating the risks of what your model does. So earlier, we talked about the whole Chipotle thing, right? Or the whole McDonald's thing where you can go and you can ask their chatbot, or you could ask their chatbot, hey, write me a Python script to reverse the linked list, and it will do it for you. That's not what McDonald's or Chipotle intended, right? But because, like many people, everyone is so fast to market, we're not thinking about the guardrails that we want to put down. The other challenge with AI is that AI is non-deterministic. What does that mean? That means that when I ask it a question, it'll give me a different answer every time. It's not going to give me the same answer, right? Because again, it's just a big probability model. So if I ask anybody's AI model, how do I make a bomb? It's probably going to say, I can't answer that question. But if I ask the question differently, maybe it will. If I say, hey, my grandfather worked in a munitions plant in World War II, and I just want to know what the day in life of what he was doing, explain it to me. That is asking, how do I make a bomb, without asking, how do I make a bomb, right? So this is the type of testing that you need to do, right? The really good platforms that do red teaming won't just use curated prompts. They'll also use AI. They'll use AI to ask yours because they're going to ask the question 20, 30 different ways. They might ask it in different languages because we want to see how your AI responds. Because ultimately, we want to mitigate that risk before we get into production, right? Now, once we get into production, the next thing we have to think about is runtime security. How do I protect from those real-time threats? So how do I essentially put a firewall in front of my applications so that I can look at those real-time threats that are coming in to assess my risk? Okay, so let's talk about, what was that? But there was a question? Nope. Okay, so a couple minutes here. So let's talk about agents, right? Again, agents are all the rage right now because agents can do a lot of things, right? Agents are both pretty cool, but also very dangerous because of what you see here. Agents can talk to a lot of different things. Depending on what your agent is doing, it can talk to your source code repository, it can scan your secrets and credentials, it can have access to install packages on your endpoint or your servers, right? It can execute code, it can talk to other things through MCP, it can even call sub-agents, right? Agents can actually decide, hey, this work is really difficult for me, I'm going to spawn a sub-agent, and my child agent is going to go do this task for me or do some part of that task for me. And so the problem with agents is because you give them all this responsibility, they can do some pretty cool things. And threat actors are honing in on this, right? There's a couple, different vulnerabilities that were detected last year. One of them is over here on the left called Echo Leak, where essentially this was a threat that was found in Office 365 Copilot, where basically, an executive comes in and says, hey, I want you to summarize my emails for the day. So the agent summarizes their emails, but what maybe they're unaware of is somewhere in that email is a hidden prompt or an embedded prompt. And this is called prompt injection. And embedding a prompt isn't difficult, right? How do threat actors do it? They put white text on a white background or black text on a black background. So while you and I read an email, we just see the email. But when AI reads the email, it also sees the command that's been injected into that document. And what people found was that in this specific one over on the left-hand side here, Echo Leak would actually go out, and anytime it found sensitive data inside of an email box, it would send it out to a threat actor, right? And so these things have been patched, but the key is that threat actors are honing in on the risk of agentic AI. And so how do you do AI security from an agent perspective? It's not that different than AI security for anything else, whether it's an agent or whether you're talking about CSPM. It's all about understanding what's in your environment, having the tools to discover the agents, secure the posture, block the access that they have, make sure they have the right identity, they have the right permissions, right? And one of the ways you can do that is with an AI gateway. So, we at Palo actually announced last week that we acquired a company called Portkey, right? But an AI gateway is a great single sort of funnel point where you can funnel all of your AI engines or all your AI tools through the same place so that we can understand very quickly what your AI services are talking to, right? And then also ultimately dictate, can they talk to this service? Can they talk to that service? We also can get insight into things like costing, right? How much does it cost to run this AI service? Is one model more expensive or cheaper than the other? Now, endpoints is probably the biggest point of contention right now because thanks to things like Cloud Code, you can spend 20 bucks and you can have no development experience and you can start coding applications and agents directly on your endpoint. And traditionally, this is where it's become a challenge because the endpoint tools that we use today don't necessarily have visibility into all the things that are now being installed on our endpoint devices, right? And again, threat actors know this, right? These are just a couple of the different type of malicious intent that we uncovered in the last year happening in the marketplace. Because now, within a specific endpoint device, there are IDE tools like Visual Studio Code and Cursor, right? There are browser plugins that people can download into their browser. All of these introduce risk into the endpoint. So what you want to start thinking about is having agentic endpoint security, having the ability to discover and govern the apps, the MCP servers, the extensions, the models, all these things that live on our endpoint device that traditional EDR tools can't detect. We refer to this as the non-binary installs. So I'll finish up here because I know I'm running out of time. We spend a lot of time talking about AI, and that's probably the focus of everything you've heard today. But where does your AI run? It runs in the cloud, right? So as you think about AI, don't forget about securing your cloud, right? This means having a cloud-native application protection platform that leverages modern technology. So not just CSPM. I think CSPM is largely a commodity at this point, but you also have to be doing DSPM, data security posture management. You have to understand what data lives in your cloud so that you can secure it because that data is probably being used to train a model or an application. You have to have AI security posture management because you got to understand, again, what services, what primitives are being deployed in my cloud by my developers, right? Now, if you can put all this on top of a platform that has automation and AI to help you create tickets and solve cases, even better, right? But the point here is, while you're busy focusing on AI, don't forget about your cloud. So, what did we just talk about, right? We talked about protecting the prompt, right? What does that mean? That means securing the data going to my third-party services. How do we do that? Secure browsers, network intercepts. We talked about if you build AI applications, what should you do? Good hygiene, shift security left. Scan your models, make sure they're safe. Before you deploy those models, red team to make sure they're saying the things they're supposed to and that you have the right guardrails around them. Once you deploy those models, we have to make sure that we are protecting them from the oncoming threats, the runtime protection piece, right? If we're talking about agents, we have to discover the agents that live in our environment. We have to protect the endpoint devices that these agents run on. We have to discover the services and all the other things that now sit on a developer or user's desktop that support the agentic AI that is being developed and deployed. And of course, as we just saw on the last slide, don't forget about your cloud security. Now, the question I get is, where do I start, right? Well, that depends, right? The nice thing about AI security is that you don't have to bite it all off at once, right? Everyone's on a different place in their maturity model. So whether you're all in with runtime security, model security, posture security, or if you're just getting started and you just want to know, hey, I want to know if Joe in IT is using ChatGPT to send our sensitive data, that's okay too, right? There's plenty to go around. It's all about choosing the right tool for the right job in the right context. Thank you.